I'd like you to look at these two equations. Believe it or not, these are the same thing. If I were to multiply all these things together, I would get this one. If I were to factor this one, I would get this one. Right now I have this green one graphed. I'll click on this one. There it is, right on top of it. Now this polynomial has an x-intercept here at -1, an x-intercept at 2, and an x-intercept at 4. Look at the connection to the factored form. An x-intercept at 2 is what would set that factor equal to 0. An x-intercept at -1, when we plug in -1, that makes this factor equal to 0. And if I plug in 4, my last x-intercept, that makes this factor equal to 0. When I take a polynomial, I set it equal to 0, and I solve it for its roots or its zeros, those are the x-intercepts. When it's all multiplied out, the y-intercept becomes clear. If I plug in 0 for all of the x's, then this last coefficient at the end, this constant, plus 8, that's my y-intercept. So I'm going to change this one. I'm going to throw in an x at the beginning. Now, if I put an x here and I solve this particular factor, x equals 0 for 0, it's going to be 0. So let's watch what happens to the graph. The whole thing's changing, but I still have those same x-intercepts I had before, and then I also have one now at 0. What if I had 2 of the same factor? So instead of an x plus 1, what if this was another x minus 2? There were 2 of them. Do you see how I have an x-intercept at 2, but instead of it passing through the x-axis, it bounces off? What if I had 3 of them? Now, it's a lot more shallow. This reminds me of a power function with a high exponent. It does pass through, but it's more shallow. Now I could rewrite this polynomial. So this one up here, I've just put all these x minus 2's together to make it x minus 2 to the 3rd power. This has x-intercepts at 0 and 2, but 2 has a multiplicity 3. Okay, so I've turned this top one off, and I'm going to mess around with this one. What if it had a multiplicity 4? The end behavior is changing. I still have those same x-intercepts, and it's getting even more shallow. Now with an even exponent, it's bouncing off the x-axis again. If I were to make it a higher even exponent, it's still bouncing off, but even more shallow. With an odd exponent, it does pass through, but the bigger it is, the more shallow it is. This has a multiplicity 5. What if I gave the 0 x-intercept a multiplicity? Watch what happens right here. It's still passing through, but now it's much more shallow.